Welcome. I'd like to show you how to create an application which is able to receive MQTT messages and to react to them, and how to deploy this application to Cloud Foundry and BTP. So first off, make sure you have an empty Git repository available like I have here. I call this one cap MQTT, and I'm hosting it on gitlab.com here. Also make sure to have Node.js installed and to have access to SAP BTP. I will provide resources and all that below. So first off, I already cloned this Git repository. And first I want to create a new branch called dev for development. Now the branch is created, and we want to develop this application using the SAP Cloud Application Programming Model. So we're gonna have to install the according dependencies first. Also make sure to add the G flag here to make sure to install the dependency globally. So after you've done that, we can check if the installation was successful by just typing cds and checking if the command works. You can see that the command is recognized, and now we can create a CAP project using cds init. But before we move on, let's first install the SAP CDS language support extension in Visual Studio Code, which is the development environment I'm using here. As you can see, I have already installed it, so I don't need to take any action here. Let's now create a file, a .cds file defining our public API. So I want to define OData functions here. The first one is called start, which is there to be able to make the application start listening to certain MQTT messages. We get the function stop, which makes the application stop listening to MQTT messages. And we get the function isRunning, which can check if the application is currently listening to MQTT messages. So now let's implement the functionality. Let's first only define the implementation for the OData function start, which is currently only returning the string hello world. We can test the functionality of this endpoint by using the command cds serve. As you can see, the application successfully started. Let's take a look at it. As you can see, we got the endpoint client, and we can now invoke the functions that are available to us. We already defined the implementation of the function called start, and as you can see, this function currently only returns hello world. Let's switch back to our IDE. Now, to be able to implement MQTT functionality, we need another dependency called MQTT. Let's install it. After the download and the installation of this dependency is finished, we can use the dependency, we can use the library inside our client.js file. Let's automatically establish a connection to an MQTT broker whenever the application starts. The URL I typed in is the URL of a public MQTT broker, which we can connect to for testing purposes. We can also define MQTT event handlers for the client, for the MQTT client we defined. For example, whenever we receive a message, we can execute a certain piece of code. But let's first define what should happen if the client successfully connects. So whenever the MQTT client instance we created successfully connects to an MQTT broker, the following code is executed. Now we only want to listen to the MQTT messages published under a certain topic. We can use the subscribe method of the client instance for that. And under this topic, every second an MQTT message is sent that we can receive. But let's first define what happens if the MQTT client fails to establish a connection. Let's also define an event handler to handle whenever the connection closes. And now let's finally define what happens whenever we receive a message. Let's first just log received MQTT messages to the standard output. Now let's implement what happens whenever the other OData functions are invoked. If the start function is invoked, we want to let the MQTT client connect to the MQTT broker, but only if the MQTT client is not already connected. For the stop function, we want to disconnect the MQTT client from the MQTT broker, but we only want to do that if the MQTT client is currently listening to messages. So whenever the start function is invoked, we check if the client is currently already connected. If that's the case, we just return service already running. If it's currently not connected, we can simply reconnect the client and return service started. If the stop function is invoked and the client is not running, it obviously doesn't make sense to stop the client, so we just return service not running. If that's not the case, we end the connection to the MQTT broker and just return service stopped. For the isRunning OData function, we can just return the value of client.connected. Let's check if everything worked. As you can see, every second we receive an MQTT message with some JSON content. Let's test the different OData functions. So first off, the client is currently started. So start should return service already running, which is the case. Let's stop the service. As you can see, the message disconnected from MQTT broker is logged. and we are not receiving any further MQTT messages. As you can see, the function is running, currently returns false, as expected, because we just stopped the application from listening to MQTT messages. Let's make the application listen to MQTT messages again. As you can see, the service is now running again. And we are receiving MQTT messages as expected. Let's quickly commit and push the newly added MQTT functionality. Now let's take a look at how to deploy this application to Cloud Foundry on BTP. To do that, we set up a continuous integration, continuous delivery instance on BTP. First, log into your SAP BTP account and select Service Marketplace. Now search for continuous integration. Select the service and create a new instance. This might take a while. Let's now select View Subscription. We can now see that we've successfully subscribed to the CI/CD service. Let's go to the application. To properly use the CI/CD service, we first need to add a few credentials. The first pair of credentials we're going to add is a pair of credentials for the CI/CD service to be able to fetch the codebase from our GitLab repository. Let's call it GitLab. We can use basic authentication here, and we can usually just use our GitLab username and password. If you enable two-factor authentication for your GitLab account, you might need to create an access token in GitLab first and use that as your password. We now need to add another pair of credentials for the CI/CD service to access our BTP to deploy the application to a Cloud Foundry space. Let's call the credentials accordingly. And for the username and password, you can just use the email address and password you used to log into SAP BTP. Note that you can't use an SAP Universal ID for this. Now let's define the repository the CI/CD service should fetch our codebase from. Let's call it cap MQTT because that's the name we gave our GitLab repository. And just copy the clone URL for the GitLab repository. For credentials, we can just select the GitLab credentials we just added. In my case, because I hosted my repository on GitLab, I need to choose GitLab as the type. Let's click Add. Now to be able to invoke the CI/CD job every time we push to a specific branch, we need to add a webhook to our GitLab repository. By clicking on webhook data, we can take a look at the information we need to create a webhook on GitLab. On GitLab, you can find the webhook settings under Settings, Webhooks. After you pasted the according information, you can select when the webhook should be triggered. In my case, I want the webhook to be triggered every time we push to the main branch. Remember that we have two branches on our Git repository, dev and main. I'm going to do the general development on dev, and every time I want to deploy the application, I merge the commits made in dev into the branch main. Let's just hit add. Now let's switch back to our CI/CD interface. We now need to create a new job. Let's call it cap MQTT as we call the repository that. Now set the branch to main because that's the branch the CI/CD service is going to fetch our codebase from. For pipeline, we can simply select SAP Cloud Application Programming Model. If we do that, the CI/CD tool automatically selects the correct build tool for us and automatically knows which files to consider. We will create a configuration for this build tool called MTA later on. Now let's scroll down and also select Deploy to Cloud Foundry Space. If we select this, every time the CI/CD job is run, the application is also deployed to Cloud Foundry. As credentials, we can simply choose the BTP credentials we created earlier. You can find the rest of the required information by switching back to the BTP cockpit. We first need to copy our API endpoint and our organization name. I only have one space in my BTP account, so I can just choose that. Also make sure to remove the trailing slash from the API endpoint. Now click Create. Now every time we push to the main branch of our Git repository, this CI/CD job is run. Now let's create the configuration file for the build tool MTA. We do that for the CI/CD job to know how to build our application. To do that, we need to create a new file called mta.yaml. First, we need to select the version of the schema this YAML file follows. In our case, we can just select 3.2. Our application is called cap MQTT, and let's just set our application version to 1. Next, we need to set some build parameters. We need to make sure to set the right build commands for the CI/CD service to be able to build the application correctly. First, we want to install all dependencies needed for production. Next, we want to execute the cds build command. We also need to set some parameters for deployment. Let's call our module MQTT again and set the type of the application to Node.js. The rest of the parameters are pretty much default values, and you can look them up in the documentation of the MTA YAML file. I'll post a link to this documentation below this video. One thing to note though is that this line makes the Cloud Foundry space automatically assign a URL to the according endpoint of the application so that the required OData functions can be accessed. Let's commit and push the changes we made. Now, as I said, to be able to run the CI/CD job, we need to push the application to the main branch. In this case, we do that by merging the dev branch into the main branch. And obviously, we need to push the changes. Now let's switch back to our CI/CD interface. We can see that one build is now running. This might take a while. As you can see, the job ran successfully. Now let's open the Cloud Foundry Spaces page on BTP to take a closer look at the deployed application. We choose our space, and now we can see our started and deployed application. We can now check the logs of it, and we can see that every second it receives an MQTT message and prints an according message to the standard output. We can also take a look at the endpoint. Here we can switch to Client and execute the OData functions we defined. We now stop the service. Let's check if it's running. It's obviously not, so let's start it again. Let's take a look at the application logs again. And we can here see the visible gap when we stop the application from listening to MQTT messages. Let's stop the application for now. Now we want to change the reaction to MQTT messages we receive, so that every time we receive an MQTT message, we call an endpoint in Integration Suite. For that, I created a very tiny integration flow. This integration flow just returns received message and then the message it received. In reality, we could use way more complex integration flows to do different things as a reaction to MQTT messages. We would use the HTTP post method to send data to this endpoint of the integration flow. But to be able to do that, we need to authenticate to Integration Suite. As we don't want to expose credentials in our source code, we need to set up a credential store to safely store this information and request it in our application whenever we need it. Switch back to the service marketplace. Here you can find the credential store service. Be aware that you can only access the credential store service if you have received the according entitlements. You can check your entitlements here. Now let's create a new credential store instance. We select our plan. And let's just call our credential store instance cap MQTT. We don't need to set any instance parameters here. We just need to create the instance. This might take a while again. Let's click View Instance now. As you can see, we successfully created the credential store instance. Let's open it. First thing we want to do now is bind the instance to the application we deployed earlier. So we just select our application and click Save. Now we can switch to the actual credential store and create a new namespace. By creating a new namespace, we are also forced to create a new credential in it directly. In our case, we want to save client ID and client secret for our integration suite instance so that our application can access it at runtime. Let's call the namespace cap MQTT. Let's call the pair of credentials integration suite. Now we need to enter the client ID and our client secret. We can get this information from the Instances and Subscriptions overview on BTP Cockpit. Just click on the one key available for the integration runtime and simply copy over the client ID and the client secret. Now create the pair of credentials. Make sure to save the value of namespace for later. Let's now implement the application logic to access the credential store at runtime. To do that, we first need a few more dependencies. We first need to install Axios and Axios OAuth client to be able to invoke the endpoint integration suite provides us. We also need to install Node Fetch and Node Jose to deal with the credential store. Let's insert the required code to deal with the credential store. For that, I'm going to create a new folder called lib, and in it I paste two files, credentials and credstore.js. This is essentially boilerplate code to deal with the credential store and partially not written by myself. Code similar to this also gets generated when using the SAP Business Application Studio to develop such an application. To paste these two files into your project, you can simply copy them from the Git repository I provided as a link below. Inside this Git repository, hosted on gitlab.com, you will also find the complete source code of the application we are developing right now. Let's create a new file called config.js in our application root directory that defines some constants we need to use in our application. Let's first define the name of the credential store namespace we created earlier. I called my namespace cap MQTT. Let's also add the endpoint of the integration flow we want to invoke. And finally, for OAuth purposes, let's also add the OAuth2 token URL required to authenticate to integration suite. You can again find it in your credentials for your integration suite. That's about it for the configuration file. Now let's make the dependencies we just added available to our client.js file. We also need a dependency called HTTPS. I'll explain that later. We are also adding our config file here and our module credentials. When invoking the integration flow every time we receive an MQTT message, we need to make sure to limit the parallel connections to the integration flow to 1. Otherwise, this would cause errors on the integration suite side. To accomplish that, we create a new HTTP agent. Now let's switch to the code that is executed every time we receive an MQTT message. To be able to concurrently deal with MQTT messages, we need this callback function to return a promise. We can do that by simply adding the async keyword to the function. So every time we receive an MQTT message, we want to first fetch the credentials from the credential store we need to be able to invoke the integration flow. Querying credentials is as easy as just typing credentials.get integration suite. Integration suite here is the name of the credentials we created earlier in our credential store. Make sure to not forget the await keyword, because we can only execute the following code once we successfully receive the credentials. Next, we want to deal with the authentication to the integration suite. We first need to send a request to the token URL we define in our configuration file to receive a bearer token, which we can use to execute following requests. Once we successfully authenticated, we can invoke the integration flow. I'm going to wrap the following code in a try-catch construct to be able to just log errors that are happening while triggering the integration flow and not make the whole application crash. We are now making a post request to the integration flow, and we are sending the content we received from the MQTT message to the integration flow and also catching the response the integration flow sends us back to log it to the console afterwards. We also need to make sure to add the authorization header, to add the bearer token to the request, and to add a content type header to indicate that we are only sending plain text. We are using our HTTP agent we created earlier here to limit the maximum amount of sockets to 1. If the invocation was successful and we received a response, we just log it to the console. In case of an error, we log the error to the console. Now we can invoke the integration flow when the application is deployed to Cloud Foundry. But to test this here in a local environment, let's just quickly add the credentials to a local file as well, so we can access the credentials from here. But please make sure to not commit this file to your Git repository, because that would expose the credentials. So to keep that in mind first, we are now going to add it to the .gitignore file. The .gitignore file is currently not visible, but exists in our repository. That is because the CDS starter project added some workspace settings of VS Code. So let's just delete that settings file first. Now the gitignore file is visible. Make sure to call your file creds.local.js because that's the file name the credentials.js module uses. Let's create this file in our root directory. Our credential is called Integration Suite. It's called like that in our credential store, so we also need to call it like that in our local file. I'm now simply going to copy over client ID and client secret for the integration suite as before. That's it. So let's test this out by just executing the command cds serve as before. Let's just stop it here. As you can see, we successfully invoked the integration flow every time we received an MQTT message. However, there is one thing I forgot. To be able to look at the actual response data, we need to use response.data instead of response. So let's quickly edit that and serve the application again. You can now see that the integration flow responded with received message and then the message we received as an MQTT message. This is also the message we invoked the integration flow with. So everything seems to work locally. Let's also test the application when it's running on Cloud Foundry. To do that, we would usually just need to push to the main branch to invoke the CI/CD job, which then builds the application and deploys the application to our Cloud Foundry space. But there's one thing left we need to do. We need to first tell our MTA build tool that at runtime a credential store is required. To do that, we need to edit the mta.yaml file. We now need to add a resource describing our credential store. In this context, I will call the credential store cap MQTT CS, short for credential store. The credential store is an already existing service running on Cloud Foundry. I also need to add the instance name of the credential store to the parameters of the resource. The name of our credential store is in this case cap MQTT. We can take a look at it here. This is the name of the credential store. Now all that's left to do is tell the MTA build tool that the application cap MQTT requires the credential store. This is done by simply adding a requires parameter. And obviously, this name, cap MQTT-CS, must match the name of the resource. Now we are finally done. Let's switch back to our dev branch and commit our changes. Let's now push our changes and merge our changes into the main branch. Obviously, we now need to push the changes here as well. Now everything's done. Now let's take a look at the CI/CD UI again. We can see that a new CI/CD job started. This might take a while again. Now as you can see, the build and the deployment both worked fine again. Let's take a look at the application in its Cloud Foundry space again. It's currently running. Let's switch to its logs. As you can see, everything is working fine. Every time we receive an MQTT message, we successfully invoke the integration flow. Let's also quickly take a look at the messages the integration flow received. In the last hour, the integration flow was invoked 84 times. Now we are finished with the development of our application, listening to MQTT messages and reacting to them. If you have any questions about the development process or about specific parts of the code, please feel free to leave a comment below. I also left some links below leading to resources on cloud application programming model and other technologies I used during the development of this application.